Hey guys, this is going to be a series of 2 videos, but in this first one, I want to show you how to divide polynomials using long division. Let's do it. Hey guys, and welcome back to your channel. My name is Franck, and if you have not subscribed to the channel already, go ahead and do so right now so you can get awesome videos like this the moment they come out. In this particular note, we're going to talk about long division of polynomial, and so let's just jump into it. If I give you an example, f of x equal to x squared plus 10x plus 21 divided by x plus 3, and so your job here is basically to divide the numerator by the denominator. In other words, is to simplify the rational expression. And so if you remember in my note number 7, I talk about how to simplify rational expression. And so if you want to know more about that, you're welcome to check that video out as well. With that being said, instead of using long division, in some cases, you can actually go ahead and just simplify the rational expression by factoring things out. And so in this particular case, if you did that, you would get on the top here, because this is a quadratic, you'll be looking for two numbers that are adding up to 10 and multiplying to 21. And so in this case, we're going to have x plus 3 and x plus 7. And in the bottom here, you have x plus 3. And so you can go ahead and just cancel out the x plus 3 here, and you should get that the division of those two polynomials, or the simplification of this rational expression, it's simply equal to x plus 7, and you should be done. But not every rational expression or divisions of polynomial is that easy to do. Not all of them will be able to be factored in this format so that you can just cancel them out. And so when that's not possible, you have to turn to long division and do it that way. And so let me show you how you would do this particular one using long division. And so for that, you're going to go ahead and start by setting up your problem here. So I'm going to have my denominator here, also called the divisor, and I'm going to have the long division symbol here, and I'm going to put my numerator inside here. And so once you're done with that, you can start with the long division. And so the first thing you should do here is look at your numerator and denominator's leading term. And so in this case, our numerator leading term is going to be x squared, and our denominator leading term is going to be x. So your job here is to divide the x squared by the x. And so if you do that, you should get x, and that's what should go up here. And so once you find that out, you're going to go ahead and multiply this x by the denominator and put your answer right here. And so we're going to have x times x equals to x squared, and x times 3 equals to 3x. And so once you have that, you're going to go ahead and subtract these two expressions. That's going to give you x squared minus x squared is equal to 0, and then 10x minus 3x is going to be equal to 7x. And then 21 here can just be brought down because there's nothing to subtract him from. And so you're going to have here 7x plus 21. And so that's basically the core of long division, because once you understand this little process here, you can just go ahead and repeat it until you're done. And so we're going to go ahead and do it again. Looking at the leading terms here, it's going to be 7x, and the leading term for the denominator is going to be the same, still x. And so we're going to go ahead and divide 7x by x, and that's going to give us 7. So we're going to go ahead and add it up here and have a 7. And so we're going to go and repeat everything. So we're going to take 7 and multiply by the denominator to bring it down here. And so 7 times x is going to give us 7x, and 7 times 3 is going to give us 21. Once we have that, we can go ahead and subtract these two expressions, and that should give us 0. So in this whole process, the denominator here is called the divisor because it's dividing the polynomial, and the numerator here is called the dividend. And what you get as a result up here is going to be called the quotient, and what you have down here on the bottom is going to be the remainder. With that being said, once you're done with your long division, all you have to do is write your function, and you do it the same way all the time. It's going to be f of x equals to your quotient plus the remainder divided by the divisor. And so in this case, we're going to have x plus 7 plus 0 divided by x plus 3. Of course, 0 divided by x plus 3 is just 0, and so we're just going to have f of x equals to x plus 7, as we had before, using the simplification of rational expression by factoring the numerator and the denominator. And so with that, let me go ahead and give you another example that you can't actually do by just factoring the numerator and denominator. So in this case, we're going to have g of x equals to 6x to the power of 4 plus 5x to the power of 3 plus 3x minus 5 divided by 3x squared minus 2x. Okay, so again, we have a numerator here, which is the dividend, divided by the denominator, which is a divisor. So we're going to go ahead and put our divisor here, 3x squared minus 2x, and then we're going to put our dividend here under the division sign. And so that's going to be 6x to the power of 4 plus 5x cubed plus 3x minus 5. Again, we're going to go and do the exact same thing we did before. We're going to look at the leading term from the dividend and the divisor. So for the dividend here, it's going to be 6x to the power of 4, and the divisor here is going to be 3x squared. So if you go ahead and divide those two things, you're going to get that 6x to the power of 4 divided by 3x squared is 2x squared, which we're going to put up here. After you've done that, you're going to take that 2x squared and multiply it with the divisor. And so we're going to have 2x squared times 3x squared, giving us 6x to the power of 4, and also 2x squared times negative 2x, giving us negative 4x cubed. Subtracting these two expressions is going to cancel out the first terms here, and then we're going to have 5x cubed minus 4x cubed, giving us 9x cubed. And then the two other expression here can just be brought down because there's nothing else to subtract them with. And so we're going to have plus 3x minus 5. And so we're going to go ahead and repeat this process. And the leading term here is now 9x cubed. Divide that by the leading term of the divisor. That's going to give us 3x. And then we're going to multiply the 3x with the divisor and put it down here. So we're going to get 3x times 3x squared, giving us 9x cubed. Then 3x times negative 2x, giving us negative 6x squared. And then subtracting these two things, it's going to first cancel the leading terms here. And we're going to have negative 6x squared, giving us 6x squared. And then we're going to have 3x and negative 5 from the top here just brought down because there's nothing to subtract them with. And so again, we can just go ahead and look at the leading term here. It's going to be 6x squared. And so dividing that by 3x squared is going to give us 2. So we're going to have plus 2 here. So 2 times 3x squared should give us 6x squared. And then 2 times negative 2x should give us negative 4x. Subtracting these two terms is going to cancel the leading terms first. And then we're going to have 3x minus 4x, giving us 7x. And then negative 5 would just be brought down because there's nothing to subtract it with. And so if you're looking at this last one here, the leading term here is 7x. And as you can see here, this 7x has a degree of 1, while the leading term of the divisor has a degree of 2. Whenever your updated dividend here has a degree that is less than the degree of the divisor, you have to stop. You're basically done with the division. So you can go ahead now and rewrite your function g of x as the quotient, 2x squared plus 3x plus 2, plus the remainder, 7x minus 5, divided by the divisor, 3x squared minus 2x. And so this is all the simplification you can do in this case, and so you can stop here. All right, let me give you one last example so that we can have this concept just sink in. And so we're going to have here h of x equals to 4 minus 5x minus x squared plus 6x cubed, divided by 3x minus 2. And so again, we're going to go ahead and write our divisor here, 3x minus 2, open the division sign, and under we're going to put our dividend. And notice that our dividend here is given not in the order of highest degree to lowest degree, but when we write it under the division sign here, we're going to have to put it in order in order to go on to the long division. So I'm going to write it here as 6x cubed minus x squared minus 5x plus 4. And so then I can go ahead and start my long division process. First thing first, our leading terms here are 6x cubed and 3x. If I divide those two, I'm going to get 2x squared. And so multiplying the 2x squared by the divisor is going to give us 2x squared times 3x, which is going to give us 6x cubed. And then 2x squared times negative 2 is going to give us negative 4x squared. Subtracting these two expressions is going to cancel out the leading terms here. And then we're going to have negative x squared minus 4x squared, which gives us 3x squared. And then we're going to bring down the other terms here, negative 5x and 4. Repeating the process here, we're going to have a leading term here as 3x squared, and the leading term of the divisor is still 3x. Dividing these two is going to give us just x, and so we're going to have to multiply the x with the 3x squared minus 2. And that's going to give us 3x squared minus 2x. Subtracting these two expressions is going to cancel out the leading terms again, and so we're going to have negative 5x minus 2x, giving us negative 3x. And then we can go ahead and bring down the 4. And again, looking at the leading term here, it's going to be negative 3x. The degree of this expression here is 1, which is the same as the degree of the divisor. So we can keep going. We only stop when the degree becomes less than the degree of the divisor, or the denominator. And so in this case, negative 3x divided by 3x is going to give us negative 1, which we can write up here. And therefore, negative 1 times 3x is going to give us negative 3x. And negative 1 times negative 2 would give us plus 2. And so finally, we can go ahead and subtract these two expressions. The leading terms here are going to cancel again. And so we're going to have 4 minus 2 giving us 2. And so this 2 here at the bottom is just a number, which means that its degree is 0. And so since 0 is less than 1, we can go ahead and stop here. And we can rewrite our function h of x as equal to the quotient, 2x squared plus x minus 1 plus the remainder 2 divided by the divisor, 3x minus 2. And so with that, we are done. And next time, I'm going to go ahead and cover divisions of polynomials again, but this time I'm not going to use long division. Instead, I'll be using synthetic division. And so if you're looking for synthetic division, check out my next video. And as usual, if you would like a copy of this particular note, check out the descriptions below. And if you like the way I break down the material, give me a thumbs up, and I'll see you in my next video. Bye-bye.